Hello guys and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we are going to have a look at how to configure layer 2 EtherChannel. So this video follows on from my previous video where we talked about what EtherChannel is and what it does. Now let's put those concepts into practice and actually see how to configure EtherChannel, and then the concepts we talk about will start to make more sense. So the commands. Obviously, we need to understand what we're doing and how to do it before we can even have a look at how to configure EtherChannel. So the commands are relatively simple. To actually get the ports into the EtherChannel, first we create that logical interface. This is known as a port channel interface, and we simply just use the command interface port channel number. So this number is an arbitrary number, and it's only significant to the local switch. So that means I could have, let's say, switch 1 and switch 2. Switch 1 could have, let's say, port channel 3. Switch 2 could have port channel 5. And that ether channel between those two switches will actually work and will actually be able to pass traffic. So the port channel number is only significant to the local switch. However, logic dictates that obviously we use the same port channel number on both sides so that we don't get confused. So it makes it easier for us when troubleshooting when we go between switch 1 and switch 2. So then once we've defined our logical interface, we then have to identify which links we want to bundle into the ether channel, and then we simply just use the command channel group number, mode, active, passive, or auto / desirable or on. And so with this command, the number after the channel group matters, because essentially we're identifying what logical interface or what port channel interface we want to associate these physical interfaces with. So essentially we're saying that bundle this link into this ether channel. So obviously that matters because the whole point is we want to bundle it into the correct ether channel. And the mode essentially just tells us whether we're using PAGP, LSAP, or whether we're going to brute force and say to the switch, we dictate to you that you have to put these links into an ether channel rather than negotiating. And then after we've done that, any configuration that we want to configure then just goes under the port channel interface, and then that is applied to the physical interfaces. So this is our scenario. We have switch 1 and switch 2, and obviously we have two links running between these switches. Those links are both configured as trunk links. So you will see that with the current setup now, one of those links will be blocked. And so switch 1, we're only going to focus on VLAN 10, and we're only going to focus on one VLAN just for simplicity. But switch 1 is the root bridge for VLAN 10. Switch 2 is not the root bridge. So what you'll see, switch 1 is going to have both links in the forwarding state and as designated ports. Switch 2, it'll have one port as the root port. The other port is going to be in the blocking state or in the discarding state if we're using rapid span entry. And then our goal is to create this ether channel. And then once we've done that, you will see that it's going to be forwarding on the ether channel. It'll just identify the port channel interface and we'll be forwarding on that, and then bundled into that port channel interface will be two physical links, and both of those links will actually be forwarding traffic. So I'm going to pause the video. Next time you see my screen, I'll be at the command line interface of switch 2. So welcome back guys, I'm on the command line interface of switch 2, and so if I just do a simple show span entry VLAN 10, as you can see, this switch isn't the root bridge. Because first of all, it doesn't list that it's the root bridge, and it also has a root port. And as you can see, like I said before, is that FA0/2 is forwarding, is the root port. FA0/1 is blocking. It's in the blocking state. It's an alternate port. So we're not using both links. So now let's create this ether channel. So the first thing we're going to do is go into global configuration mode, use the command interface port-channel. As you can see, I can literally choose any number. All you have to make sure is that on a single switch, you may have multiple port channels, multiple ether channels configured. So obviously this just identifies or is locally significant to identify the port channel or the ether channel on that switch. So in this case, I'm just going to use port channel 10. Okay, and that's it. So we've created the port channel. Great. Now we have to identify which interfaces I want to bundle in to the ether channel. So I'm going to exit from here, do a show IP interface brief, and as you can see, I've got two interfaces. FA0/1, FA0/2 are both up. If I do a show running config int FA0/1, as you can see, just configured as a trunk, and FA02 just configured as a trunk. So now all I do, first of all, we are going to configure PAGP. I just go under the interface, FA0/1, and then I just use the command. I use command channel group. Okay, 10, because obviously I want to bundle this into port channel 10, associated with port channel 10 mode, and then we just define whether we want to use PAGP, LSAP, or whether we just want to brute force our way in and just say, look, I don't care what you say, buddy, you are going to be assigned to the port channel. In this case, we're going to use PAGP first. So obviously I'm going to configure this side with desirable, because one of the sides has to be configured as desirable, otherwise they won't form an ether channel, because they'll both be waiting on the other side to begin the negotiations. I literally just do the exact same thing to FA0/2. So channel group 10, and the mode, let's say that desirable. So it's worth noting that I don't have to configure desirable. Actually, let me see that actually. So if I do auto, what does that do? Okay, so that's fine. That means that so we can mix and match desirable and auto on our individual links on the same switch, because all we're basically saying that we're using PAGP, but over this link, I won't be actively trying to get this link into the ether channel. I'll passively wait on the other side of this link to suggest to me or to stop the negotiations. So that's perfectly fine. Obviously, I'll just change that channel group 10 to desirable just for simplicity's sake. So desirable. Now if I exit from here, if I do a show EtherChannel Summary, this shows us just brief information about all of our ether channels that we have on the switch. As you can see, FA0/1 and 0/2, they're both bundled into the ether channel. Let me do that again so we can get the correct information. And at the moment, the ether channel is SD, so it's a layer 2 ether channel. It's currently down at the moment, so there's no links bundled into the ether channel. And FA0/1 and 0/2, they've got the I flag, meaning they're standalone. So they're not currently bundled into the ether channel. They're still seen as standalone links. And the reason being is because the other side hasn't been configured. So the other side is not participating in the negotiation process to get these links bundled into the ether channel. So now let's go over to switch 1 and do the configuration on switch 1's end. So I'm on switch 1 now again, and just to show you that the port channel number doesn't matter, I'm going to configure this as port channel 1. Now obviously I wouldn't recommend this in a live environment. It just makes things complicated for no reason. So to be fair, it just makes sense to just have the port channels to be the same on both ends of the ether channel. It just makes sense. It's just easier for us to understand. You don't want to make stuff more complex for yourself for no reason, because there is no benefit. But just for this lab, I'll show you. So port channel. There we go. Oh, sorry. Interface port channel. Interface port just channel. Let's go 5. Okay. Interface FA0/1. I'm going to say channel group. Okay, 5 mode, and let's just put auto. Let's configure this side as auto. We can configure this side as desirable or auto, but let's just configure it as auto. If I go now and say interface FA0/2 channel group, and I'm going to put 5 mode auto. Okay, again, it takes a few seconds for the link to go up, to go down, then come back up, etc. As you can see, port channel 5 is now changed to up. If I do a Control Z, okay, switch 1, so okay, that comes up. If we do another show EtherChannel Summary, as you can see, P means bundled into the port channel. So now this link is part of this port channel. It's part of this ether channel. It's up. It's a member of this ether channel. And again, we'll have to wait a second for FA0/2, but if we do show EtherChannel Summary, that's bundled in as well. So now if I do a show span and tray VLAN 10, and this is pretty awesome. As you can see, it no longer sees FA0/1 and FA0/2. It only sees the port channel. So the way that this logically works is that when the switch wants to forward traffic over this port channel, it's like, okay, I want to forward traffic to switch 2. I can reach switch 2 via port channel 5. So I send the traffic to port channel 5, and then using my load balancing algorithm, I will then select a member link of port channel 5, either FA0/1 or FA0/2 to actually forward the traffic physically over. So as you can see, it doesn't even see the individual links. These links are now part of a group. They're part of port channel 5. He only sees port channel 5. And now again, this is pretty awesome. So now if I go over to switch 2 again, and if I do show EtherChannel Summary, as you can see, bundled in, that's fine. If I do a show, and as you can see, the EtherChannel works fine, even though the port channel numbers are not the same on both sides. You can do that, but again, you wouldn't want to, because why introduce more complexity for yourself for no reason? There is no gain for us. So again, if I do show span tree VLAN 10, as you can see, now it just identifies port channel 10. So it's saying that port channel 10 is my root bridge. I don't even see the physical links. So now I'm actually forwarding traffic on both of my physical links. So now if I do a show spanning tree, let me see this actually. If I do show spanning tree VLAN 10, interface FA0/1, does it recognize that? So interface, so show spanning tree VLAN, sorry, 10, interface, yeah, interface FA0/1. As you can see, that's forwarding. FA0/2, that's forwarding as well. But if I do a show spanning tree VLAN 10, as you can see, it only identifies the port channel as being part of the spanning tree topology. The individual links, they have been bundled into the port channel, so now they're forwarding. It's literally as simple as that, and that is PAGP configured. Now, let's go and configure LSAP and on. So now what I'm going to do is I'm going to go over interface port channel 10. Let me show you something as well. So interface port channel 10. Let's shut this down. Show you something. If I do a show interface FA0/1, as you can see, those interfaces are down now. So if I do a show run int FA0/1, as you can see, that's down. So as you can see, one command applied to the port channel now applies to all the members of that ether channel. So let's go under interface FA0/1. So if I do show run int FA0/1, as you can see, channel group 10. If I do channel group 10 mode active, we're using LSAP now. Oh, that's awesome. So as you can see, we can't just change it from PAGP to LSAP. So instead, what we have to do, we have to negate the command first, no channel group 10. And then reconfigure channel group 10 mode. Let's go active. Now that's LSAP. Oh, that's good. So the reason why it won't let me now add this to the ether channel, because there's already another link added to the ether channel which is using PAGP. So I have to essentially drop all of the links out of the ether channel and then add them back in. Interface FA0/2, no channel group 10, channel group 10 mode active, channel group 10 mode active. That's fine. If I go interface FA0/1, channel group 10 mode active, brilliant. Now if I do show EtherChannel Summary, as you can see, LSAP. So it'll actually tell me which protocol we were using. So if I actually scroll up a second, let me just see. I'm pretty sure it tells us with PAGP as well. Just give me a second. Let me just double check. So might be quite a long way up actually. Just bear with me. Yeah, here it is. Yeah, so it actually tells you what protocol is being used, whether it's PAGP or whether it's LSAP. So that's brilliant. So now I'm not going to bring this up yet. I'm going to go over to the other side first. Let's go over to switch 1 because I don't want there to be any sort of conflict. Let's go conf t interface FA0/1. Let's go no channel group 5. Interface FA0/2, no channel group 5. Now do channel group 5 mode active, interface FA0/1, channel group 5 mode active. Brilliant. Let's swap over back to switch 2. Let's bring back that port channel. So interface port channel 10, no shutdown. See what happens there. As you can see, both of the links are now. So it brings down the port channel, brings those physical interfaces back up. If I do a show EtherChannel Summary, as you can see, those are now bundled in. If I do a show spanning tree VLAN 10, As you can see, it doesn't even see the physical interfaces. Spanning tree topology only sees the port channel. It's forwarding on the port channel, which means that all the physical links, which are members of the ether channel, will now also be in the forwarding state and will also be identified as one link. So it identifies the port channel as one link, identifies all of the physical interfaces which are members of the port channel as a single link. So it doesn't even identify them as separate links. Some other commands we can use, I'll show EtherChannel. Let's go detail. So this shows us detailed information about our ether channels that we have configured. As you can see, it's a layer 2. So we can configure a layer 3 ether channel, and the benefit of that is that layer 3 interfaces. Each layer 3 interface is a separate broadcast domain. What you can do is you can take multiple layer 3 interfaces, combine them together, essentially bundle them into an ether channel, and then you would configure the IP address information on the ether channel. So even though those are layer 3 interfaces, logically they're now part of the same broadcast domain, and we still get to terminate broadcast traffic as well. So as you can see, max port channels. So with LSAP we can have 16 channels, or 16 links bundled into the ether channel. However, only 8 of those links will be active and forwarding traffic in the ether channel. The other 8 will be in standby, and obviously if one link goes down, one of the standby links can come back up. So port channel up, master association, as you can see, active channel group 10, port channel 10. So FA001 SA, so the device is sending slow LACP PDUs, etc. Device is in active mode, so as you can see FA001, that's in active mode. So is FA002. So as you can see, the A is active, and obviously P is passive mode. So the passive mode is just standby. In that it's not actively forwarding traffic for the ether channel. It will do if it needs to. Obviously, if one of the active links go down. So again, FA002, so port FA002. See, that's now SA as well, so it's active in the ether channel, all that sort of good stuff. So now that's up, simple as that. And now I'm going to bring the link down again, the ether channel down, and let's just configure on mode. So on mode is slightly different. So if I do interface port channel 10, let's go for a shutdown again. Interface FA001, no channel just group. So as you can see, I have to unassign all the links from the ether channel before changing what method we're going to use to establish the ether channel. Interface FA002, no channel group, that's fine. Then channel group 10, mode on, brilliant. Interface FA001, channel group 10, mode on, fantastic. If I do a show EtherChannel Summary, as you can see, it doesn't show a protocol. So if you see output and there's no protocol, if there's no LSAP or PAGP, it means we're using the manual configuration. We're dictating to the switch that, yeah, you have to bundle these into the ether channel. And at the moment, it's listing D for down because obviously the port channel is down, so these won't be up. That's fine. So let's go over to switch 1 quickly, and let's just configure the exact same information here. So again, so let's go interface FA001, no channel group 5, interface FA002, no channel group 5, and then channel group 5 on, mode on, interface FA001, channel group 5, mode on. Brilliant. If I do a show EtherChannel Summary now, as you can see, yeah, so the links are physically down. That's why they're not being bundled into the ether channel yet. Okay, so down, etc. All that sort of good stuff. Now I'm going to go back over to switch 2, and I'm going to bring these back up. So conf T, interface FA002, sorry, port channel 10, port just channel 10, no shutdown. Give a second, those links will come back in a minute. Because obviously they're now part of the ether channel, so any commands we apply to the port channel interface will automatically be applied to the physical links. That's fine, brilliant. So if I do a show ether channel summary, it lists those links as, yeah, just being bundled into the port channel. Let's look at some other commands. Show ether channel. If you go detail, so what does this show us? So as you can see, it just shows us that FA001, okay, so that's bundled into the ether channel. Mode on. So that's already lists. We can have up to, so with when we use manual configuration, and since we're dictating to the switch to bundle these links into the Ether channel, and we are using LSAP, we're only limited to max ports of 8 to be bundled into a single Ether channel. That's the same with PAGP as well. So as you can see, with the on mode, it just lists that port as being in mode on, and essentially just being up, because obviously we're just dictating the switch to enable these links no matter what. So that's fine. So show Ether channel. Let's look at some other commands that we can use to see more information. Let's see port channel. What does that show us? This shows us, okay, so this is good. This shows us information about the port channels that we have configured. So it shows how long that port channel has been up for, number of ports, whether port security is enabled. Port security we'll get to later inside the security section. That's a layer 2 security feature where we can essentially have control over what MAC addresses we can see on each port. Well, I'll get into that a bit later. Brilliant. So it shows all that sort of good information, logical slots, just port, number of ports, etc. Port state, all that sort of good stuff. Show Ether channel. What other stuff can we see? So Ether channel. Let's do protocol. What does that show us? So it just shows us whether we're using LSAP, PAGP, or manual configuration. So to be fair, I think that's really everything covered with the show Ether channel command. The other thing I want to show you guys is do a show Ether channel load balance. This is good. So this will tell you how the switch is going to load balance traffic over an Ether channel, and we can configure this based on a global scale. So essentially, we can change the load balancing method for all Ether channels associated with the switch. So as you can see, currently we're only using source MAC address to load balance traffic. So let's change that. Let's go to if I go to port channel load balance, and I want to choose, let's just choose source IP for now, because I think that's going to probably be easier. Source IP. Control Z. If I do a show Ether channel load balancing, as you can see now, it's going to be the source IP address for load balancing traffic. For any non-IP information, it will still use the source MAC address, but to be fair, all of the traffic in our network is going to be IP based, IPv4 or IPv6. So that's fine. So I want to show you this other command as well. Test Ether channel. I'm not going to tell you what the command does, but you'll see in a second. Port channel interface, go port channel 10. Let's go IP address. Let's just say 192.168.10.1. Destination 192.168.10.2. Sorry, yeah, 10.2. So, yeah, so you can see that with this test command, we can actually see what physical link inside the port channel or inside the Ether channel that this switch will use to load balance traffic if it saw traffic with this source IP address going to this destination IP address. Now, the load balancing is only done based on the source IP address. So it's saying that if I see a source IP address of 192.168.10.1, I will send over this link. And to actually prove that, let's change that. And as you can see, we changed the destination IP address, and we still get the same result. I'm still going to use the same interface to forward traffic over this link. So what this is saying is that any traffic I see with this source IP address will always be forwarded over this link inside the Ether channel. Let me change this now. So let's go, let's say 22, FA0 is 2. Let me see 21 actually. So let's go 30. Yeah, okay, yeah, so that's good. So as you can see, now we're saying that, so 22, 21, I'll still forward over that same physical link. However, if I see 192.168.10.30, I'm going to forward that over FA0/1. Even if I change the IP address, let's say we change it to something completely different, it's still going to use FA0/1. So what this command allows you to do, so this command, just so you guys know, is test Ether channel, and then we define load balancing interface, port test channel. We define the port channel interface number, and then we define the IP, source, and the destination IP, or source MAC and destination MAC, or source IPv6, destination IPv6 address. What this command allows us to do, it allows us to see how the switch would actually handle the traffic within our network. So what you may want to do, you may want to fine tune your Ether channel load balancing. So what you may think, okay, what is going to be the most common type of traffic between these two switches? So who are going to be the guys who are talking the most? Maybe on switch 2, we have a server. Sorry, yeah. So maybe on switch 1, so obviously we're on switch 2. Maybe we have a server on switch 1. So obviously we're going to have multiple devices communicating with that server. So how would you load balance? You wouldn't want to load balance on destination IP or just destination MAC, because all the devices or the majority of the traffic is going to be going to the same IP or same MAC, meaning that that traffic is going to be load balanced over the same links. However, if the traffic is coming from different sources, what you may want to do is just load balance based on source MAC or source IP address, because that would make the most sense, because we are going to have, or essentially the switch would choose different links based on the different source IP addresses. If we just load balance based on destination IP or destination MAC, chances are we're going to get the exact same link being used for all traffic going towards that server. So this is good, because this allows us to essentially check what kind of load balancing we'll have based on the majority of traffic we're going to have in our network. And guys, that's it for EtherChannel. So it's really that easy to configure, literally just a couple of commands. And then obviously once you bundle them in, so I think, sorry, actually wait, let me go back, just give me a second. There's something that I didn't show you guys. So guys, we're back at the command line interface. So it's something that I forgot to show you. So now if I go to conft, let's go interface port just channel 1, no, sorry, 5. It's first 10 here, sorry, 10. So if I do show EtherChannel Summary quickly. So let me get out of this, sorry. Show EtherChannel Summary. Okay, yeah, so it is port channel 10 and port-channel 10. Any commands I want to apply have to apply here now. So I could do switch port trunk native VLAN 10. I could do switch port trunk allowed VLAN. Let's say 10 and 1. Let's say I want to do what other commands can we do actually? I could do speed and duplex here as well. Speed 100, duplex full, etc. Do all this sort of stuff. Let's say I want to do CDP enable. That's all good stuff. If I now do so I think I just broken that ether channel. Let's go. So should let me do switch port trunk. Actually, let me do no CDP enable, because I'll stop receiving no CDP enable. That's fine. Okay, if I do show running configuration interface port-channel 10, this is the configuration now on the port channel. If I go to, let's say, interface FA0/1, okay, as you can see, the same configuration is applied to the physical interfaces as well. So as you can see, we only have to apply the configuration in one place for it to apply to all the other members of this port channel, of this ether channel. And now let's say, actually, let me show you something. If I want to do FA0/3, let me see, I want to bundle this into the link, into the ether channel link. If I do channel group mode 10, I don't know if this will actually give me the desired result, purely because that interface is down at the moment, but it's always good, worth a check. Mode on. Okay. Show EtherChannel Summary. So it won't give me the desired result at this point in time, but essentially if this link was up, what you would see is that it wouldn't actually be active in the ether channel. The reason being is because the configuration is completely wrong. So that brings me to another point. If I wanted to bundle a new link into an already active ether channel, what would I do? Simply just do this. So I'll go to, let's go back to interface FA0/3. Let's do no channel group 10. I do show run int FA0/1. I'll literally just copy all this configuration. I'll paste it over here. That's fine. And then I would just do channel group 10 mode on. And so that's what you do. So if you already had an active ether channel and you wanted to add another link into the ether channel, you'd have to make sure that before you bundle that link, the configuration matches what's already configured on the ether channel, and then bundle it in. And so you will see that whether you use HP switches, Juniper switches, Cisco switches, that's how it would work. You would have to make sure that the configuration matches which is already configured in the ether channel, and then bundle that link in. Okay guys, so this really is the end of the video. So as you can see, ether channel is easy to configure. Literally just 2 commands to actually create the port channel interface, then bundle the links in. Then obviously any commands we configure afterwards are going to be applied to the port channel interface. And as you can see, with Spanning Tree, we were able to actually see that before ether channel, both links were identified as separate links. After EtherChannel, it just identifies the port channel interface in the spanning tree topology. So it's going to be forwarding on the port channel interface, meaning any links which are members of that port channel interface will also be forwarding. It doesn't actually see the member links in the STP topology. It only sees the port channel. Then obviously once it comes to forward traffic, based on what physical link we're going to use, will be based on the load balancing algorithm configured on the Cisco switch. So that's all there is to it. So thank you very much for watching. If you have enjoyed this video, then please subscribe to my channel. Thank you very much.